play a major role in your career in the future. Today we're going to talk about what are the things comprised of software engineering. What do we need to pay attention to? The next time, hopefully we're going to talk about tools. Just like any kind of engineering discipline, you got to use tools to become an engineer. You need a hammer, you need a screwdriver, and similarly you need debuggers and testing tools, documentation tool, and all these good things for software engineer as well. All right. The next Thursday, we're going to kick off our project by giving you the initial specification. Okay. The specification is not meant to be crystal clear. That's part of your job to clarify the requirement, so you can basically nail it down with your customer. Right? So we all have somebody running the project. Basically, your job is to read the specification from her and ask questions and clarify things, so that you can come to some action items you can put down, and that's going to be your action plan. Okay, so that will happen next week. All right, this week hopefully we are stabilizing the roster for our class, so you guys will be able to see the project next time. All right. Again, we'll have a quiz today, just like last time. Hopefully, you guys all have brought your device, so you can start coding on your device. Starting today, we'll have somebody come here and write code on the board. Okay. Again, the code itself is not for grading purposes. This is just for you to show you're here, participating in the class, and also gain the practice of writing code. All right. Certainly, if you write your code on the whiteboard, for instance here, it's not going to run. That's okay. I mean, that's actually part of the game. For those of you who are coding on your computer, I would encourage you to start coding into IDE editors rather than coding into Notepad. Okay, Notepad will not run your code. And D2L website doesn't run your code either. We have plenty of other websites which can run your code actually, but D2L doesn't have that functionality.
But so the quiz is on D2L.
The quiz question is on D2L. Okay? Then you can code into your own IDE or favorite editor, which you can use to compile your code and run your code. The goal is that when you write your code should execute, right? There isn't that much benefit if your code cannot execute, right? So gradually we would like to transition you into coding something that's running, okay? Instead of just write down the code, all right? Write down the code doesn't give you much benefit beyond just writing down the code. Yeah, you can review the code to check for errors and bugs, but certainly you want the code to run. So starting today, I would encourage you to start writing code into an IDE. For instance, Eclipse, if you like to use that, or some other tool you like to use for Java, just so that you write the code, and this will also give you a chance to write running code, right? So you guys are pretty much used to when somebody gives you the skeleton of a program, you are filling in the void in the program so that the whole thing can compile and run. And this is also time for you to set up that skeleton yourself. For instance, we had that first quiz last time, which is LinkList. If you can decide to just write down the class for LinkList, but that if you just write down the class for LinkList, probably it doesn't run. Okay, so which means that you have to create a test harness around that LinkList, so that your test harness will invoke your LinkList to do a real thing. That's the time when you can test your program. So let me explain what I mean by that. So if you have a class, oh man, this one. Hopefully we have pretty much, when you write a piece of code, just simple module, say this is your class, right here. Okay, you can give a name, probably a linked list. Linked list will be here. Then you have your attributes right here. In this piece, then you have your methods as well. Okay, this piece of code looks pretty nice, straightforward. I mean, you have the name, you have attributes, you have method, you have implementation of the method in there too. However, this thing doesn't run. Okay, because it's essentially a library of code. No one is calling it to do anything, right? So to make this run, what you need to do is actually add a harness around this guy. Okay, then this is really going to be the main program. Okay, when you go into, then you are setting up to call these functions in the method to do real things. Okay, so used to be you are only coding this part, filling in the void. That's a lot of you used to. But now, as we write our quiz, I would like to encourage you to not only code the class itself, which solves the real problem, but also setting up a test harness. Okay, so this is also basically the way how industry people test their own code as well. Okay, so this is basic fundamental unit testing. All right, so you write your own piece of code in your class, but you also create a test harness here, which basically call into your your class. This is your unit test. Okay. So basically, if you work in any real company, if you don't have this piece provided, you cannot check in your code. But
so in Java, I know we can write a main function in each class to test it. Is this what you're referring to? Or do you mean a separate main class?
Separate main class.
Yeah.
So yes, you're right. So I can always add something here to make it executable. Basically, I can execute that class, right? You can just Java that class. But that's actually break the purpose of that class, right? That class is not supposed to be the main class. It's supposed to be a component or a class that's being called upon by other classes, okay? So if you have a main function here and you go into this, you actually committed a crime, quote unquote, in terms of software engineering, because you actually just break the modularity of that class. Okay, so if you are going to you're implementing this class, the only way you should be doing this is to call the function outside, not actually modifying itself to create a testing environment within. You should always put your unit test around it rather than inside. Okay, so this way I can take this out, I can swap your code out, I can swap his code in. I actually can use the same test harness to test that same program. Okay, and also because I have a standard interface right here, I can move this and plug into another piece of code, and it actually give you the functionality you need in LinkList. Right? That is exactly the purpose of unit testing. Right? So you test this module, or the test code should not be in the implementation. Right? You actually need to, because this is all you want and all you need. You just need to keep it as a module, and other things, the testing environment should be in a separate module. That's a test class. Okay? And the good sound unit testing is for each class you have a unit testing class to pair with it. That's also the concept behind some tools like JUnit. Okay? JUnit just make this easier to write. It give you a skeleton for this, so you don't have to create your own format. You can just use JUnit will automatically generate this for you, and then you can essentially write the call easily, make it easier for you. But nothing more than that. JUnit basically is that. Okay. You have a follow-up question?
No, I think we're good.
All right. So that is the fundamental thing I think you guys on this level should understand and master, which is when you are writing a class, think about how you are going to unit test your class at the same time. Actually, even better, is so-called test-driven development, which is you code the surrounding test environment first before you write your own class. Okay? That's even better software engineering practice. Okay? And then in real testing, then every night, actually all these tests will be run in batch to keep you from actually create problem for yourself. So essentially, when you add new functionality to your code, you are not messing up with existing functionality already implemented. Which actually happen a lot more often than you think. Okay? And this unit testing, if you set up unit testing for each class you implement it and enforce this principle strictly, then this will keep you from making many mistakes. Okay? And to come back to your point, if you implement things within to test your class, you actually sometimes give yourself a wrong impression about this class. Because within this class, you can do many things you cannot do from outside, right? So the best way to create reusable test cases is actually put all the test cases in the test class and only call the interface of the class you test, which is the DUT, basically your module under test. Okay, so this way, if you only call this, your test is reusable, as long as your interface is not changing. Okay, you only need to modify those test cases when you change your interface. You don't have to make any change to the test environment if you actually make any improvement or optimization to your own class. Okay, so this is modularity, and this is actually the way to get rid of most of your coding bugs. Okay, come up with test cases that's going through the front door, not from a side door. Side door is always very dangerous. Always go through make sure that you always go through the front door. I mean, back door is always bad. Side door is dangerous. I mean, front door is always the way to go because you want other people to use your class from front door as well. Okay? Does this make sense? When we use a tool like JUnit, some people call it test automation tool, right? Which sounds really great, right? Oh, somebody can automate my test, which is actually very misleading because they just provide you a template so that you don't have to write this every time. You push a button, you generate this. But how you are going to test your program, actually you have to write that down yourself. Okay? It's automated. The running of your test is not automating your test. Okay? So if you have those test cases identified and written down, then your JUnit can automatically run them for you. But it's not going to automatically generate those test cases for you. Who generates those test cases? Either you or your testing buddy. Okay? If you're lucky, you have some testing QA work with you. If you're unlucky, the QA is yourself. Okay? So if you are in pair programming, maybe you guys are actually a QA to each other, right? But a lot more time you are the QA, first line QA yourself. Okay? So just understand the basic. This is very basic, and also should not be more complicated than this, right? You actually set up your test class before you implement your own class. This is test-driven development because you are essentially putting in all the requirements here and testing your class as you go. The chance you make mistake and introduce bug will be far smaller. Then you just code this whole thing up. Then think about how to test this because you will be biased. Right? If you start from test, you are actually, from your own point of view, you're more objective than having your class implemented. I already know the internal working of this class. Then you think about how best test is. Well, you'll find that in many cases you actually are very biased against. I mean, for your own class, you always try to come up with clever ways to make it work, right? But that which is actually going to create a lot of problems, right? So optimization is great, Only when you have a stabilized functionality all tested, then you go with your optimization. Don't try to optimize before you even have the first implementation. You're wasting your time, okay, essentially. And also you introduce clever bugs. It's going to take you a lot of time to debug. Okay. All right. So this is the basic concept in unit testing. We'll cover later on a lot more in our lectures. All right. So today we're going to talk about so what do we need to worry about in terms of software engineering. So we'll look at the beautiful theory for software engineering and the messy practice. And also very important concept we'll emphasize many times is software engineering is a very repetitive process. It's not streamlined, get it done, that's it kind of thing. It's always repetition, iteration, increment. It doesn't go as a big chunk. Which is, for instance, you don't want to write down 500 lines of code, then start debugging. Okay? So it's not Stone Age anymore. Running the compiler and debugger doesn't take you that much time. Okay? Unless when I started, I have to run tape to get my program in. That's why we had the habit of 500 lines of code all together, then debug. But for you guys, that should never happen. Okay? That should never happen. You should just go, whenever you put in, 10 lines of code, you should already be debugging those 10 lines of code and make sure they are correct. Okay? That's already enough for you to look at. So you don't want to write a function of 500 lines and start debugging that function. There are two things wrong with that. First of all, your function is too long with 500 lines of code. The second thing is if you haven't looked at the code, debug the code, even compile the code, the 500 line of code, then you have a lot of bugs inside already. Okay, it's not recommended. All right. Well, we'll touch on unified process. Which basically give you some basic notations for writing down your requirement, writing down your design, writing down your test, writing down your final delivery documentation, and so forth. Don't be too fixated on that in the sense that the process is rigid, but the human is flexible. So what process you actually go to run actually depends on yourself and your team, not say the textbook. Okay, so this just provides you the basic building material you can assemble together to build your own process. For instance, how you represent user requirement, how you represent your own design, how you write down test cases, how you communicate with your teammate. They just give you the basic tools and format and exchange, and so you can use, but not say you have to exactly follow the process. Okay. We'll touch on team and also something you always need to consider, which is the cost-benefit analysis. It's easy. So just like why you are here taking computer science as a degree, you must have done some mental calculation of the benefit of the return of your investment. Then, if you haven't done that, you may actually take my class off today and think about that, right? Because that's more important than listen to one single lecture on software engineering. Right? If you haven't figured out why you are here, studying a degree, then you better spend time think about that. That is actually cost-benefit analysis. You're spending your time here. You're basically, for most of us, our best asset we have. You're investing money as well, paying tuitions. Then you better get something in return. That is our cost-benefit analysis. You must have predicted that your return is way bigger than your investment. Unlike a history degree, which basically are the other way around, right? So you must have done that pretty well. Otherwise, you should be spending time thinking about this right now, okay? But how you do that analysis? You need a set of metrics, which basically say what are the indicators I need to look at to make my decision, right? If you don't measure, how do you know whether it's good or not? That is matrix. So we also have basically a case is to basically talking about tools, right? And you can see that this is very, very high on our list, which is you need to know version controls and configurations, okay? Because if you don't use that, you are going to waste a lot of time. You're going to lose a lot of your code. You would not be able to figure out what exactly is the right version of the code you should be using. So yeah, that's very high on our list. Something more, we're going to talk about testing, and then we're going to introduce the concept of execution-based testing and non-execution-based testing. Here, what I'm saying, this is actually execution-based testing because you actually set up your test environment, hook up with your class and run that through compiler and into binary code, bytecode and run on Java virtual machine, and it will give printout result for you, or you can use debugger to look inside the execution. So this would be so-called execution-based testing because you are actually running the code, right? Also something called non-execution-based testing. What would that be? Static check, that's actually an advanced format of our non-execution-based testing. What is the most basic way of doing non-execution-based testing? Whiteboard definitely is one. That's actually it's a major one. What else? Non-execution-based testing. You guys do this all the time, okay? You guys actually do this more than you are aware of.
Read the code level line and
Read the code.
some logic.
That's basically it. You eyeball the code. Okay? Static check is actually a clever way of using tools to help you eyeball the code without you eyeballing the code, right?